Aldol condensation reaction is given by only aldehydes and ketones that contain alpha hydrogen atom. So aldehydes and ketones contain alpha hydrogen atom. So not all aldehydes and ketones can give this aldol condensation reaction. This one is a condition. Alpha hydrogen atom must be present. Consider acetaldehyde. So here this carbon atom is alpha carbon and there are three hydrogen atoms on this carbon and they are known as alpha hydrogen atoms. Alpha hydrogen atoms are highly acidic due to the presence of this carbonyl group. Now in aldol condensation reaction, this aldehyde reacts in the presence of dilute NaOH. We know NaOH ionizes to give Na plus and OH minus ion and it abstract one of the alpha hydrogen from there. Why? It is highly acidic in nature. So it abstract as H plus ion and you will get CH2 minus CHO. Why there is minus? When this hydrogen moves with OH minus as H plus, these two electrons will move back to the carbon atom. So you will get CH2 minus CHO. Now again it reacts with another molecule of the aldehyde. So here you can see there is a carbonyl group. Carbonyl carbon has a partial positive charge there. So this negative charge attacks on this carbon. Then this pi bond will shift towards the oxygen atom since it is highly electronegative. So the resulting compound will be, so I will start from here. So CH3, then carbon is attached with one hydrogen. Now oxygen is O minus. Now this carbon is attached with the CH2 group and CHO is there. Now, this compound will abstract one H plus ion from the reaction medium. Then you will get CH3, CH, OH, CH2, CHO. So here this one is the alpha carbon and this one is beta carbon and we are now having a beta hydroxy aldehyde or aldol, ALDOL. So here ALD indicate the presence of aldehyde and OL indicate the presence of OH. So it's a beta hydroxy aldehyde. Now on heating, one molecule of water will be removed. This is OH and one of the hydrogen atoms here gets removed as water molecule. That is why it is known as aldol condensation reaction. So aldol is formed in the third step. Now the last step when you heat, one molecule of water gets removed. So the name aldol condensation reaction, you are getting CH3, CH, double bond, CH, CHO. So here is alpha, this one is beta. You get alpha, beta, unsaturated aldehyde. And this reaction is known as aldol condensation reaction. Now we will consider another example. CH3, CH2, CHO. We know that two molecules of aldehyde is required for the reaction. So two molecules of CH3, CH2, CHO in the presence of dilute NaOH. What will be the product? We know the mechanism CH3, CH2, CHO in the presence of this OH minus ion. OH minus ion will abstract one of the alpha hydrogen. So always remember here we have two carbons. One carbon is an alpha carbon and one is beta carbon. So always alpha carbon will be removed as H plus ion. Why? When you come to the beta carbon, the carbon is far away from the C double bond group. Okay, so the acidity of the hydrogen atoms present on that beta carbon is less compared to alpha carbon. Alpha hydrogens are more close to the carbonyl group. So their ability to get removed as H plus ion is very high. So always alpha hydrogen gets removed there. Then you will get CH3, CH minus, then CHO. Now this one reacts with another molecule of CH3, CH2, CHO. Now the negative charge attacks on this carbonyl carbon and then negative charge shifts here. Then you will get, so I will start from here, this CH3 group. So CH3, then CH2. CH2 is attached to one carbon and a hydrogen, and carbon is attached to one O minus. Then now a new bond is formed between the CH, and CH is attached with one CHO group and one CH3 group. So this CH3 is this one. Okay. Now O has a minus charge, so it abstract one proton from the reaction mixture. You will get CH3, CH2, then CHOH, CH, CH3, CHO. So here you can see that this is alpha carbon and this one is beta. So beta hydroxy aldehyde. So this is an aldol. So aldol is a general term for the compounds that contain a hydroxy group on the beta carbon of an aldehyde. So this one is a beta hydroxy aldehyde. So it's an aldol. So aldol on reaction or on heating. On heating, I will remove one molecule of water. How? OH from the beta carbon and hydrogen from the alpha carbon. It gets removed like this. Finally, you will get CH3, CH2, CH, double bond, C, CHO. There is a CH3 group also here. So finally, we get an alpha beta unsaturated aldehyde. Alpha beta unsaturated aldehyde. So this is the reaction. Now we will see how to get the products of aldol condensation reaction easily. Here in both the examples, we have done the full mechanism and then we got the reaction. Now we will see how to do this reaction, how to get the product easily. We know that two molecules. First example we can take two molecules of CH3CHO we use, right? And dilute NaOH. And always we need two molecules of CH3COH and alpha hydrogens will be removed. Write the compound CH with two alpha hydrogens like this. So this is the first molecule and two alpha hydrogens, I wrote it with bond, and the second molecule just write it below it like CH3 C double bond H. So this is the first molecule of aldehyde and this is the second molecule of aldehyde, and these are the alpha hydrogens. And you remove one molecule of water from here, then you will get, so start writing from here. So CH3, then CH. Now this double bond is broken, right? So now a new double bond is formed between this carbonyl carbon and the alpha carbon CH. So this is the product you are getting. Okay, so alpha beta unsaturated aldehyde. Now this was our first example. Now our second example was two molecules of CH3 CH2 CHO in the presence of dilute NaOH. So write the same way. First molecule you write CH3, then see this is the alpha carbon, right? So this is the alpha carbon. So two hydrogens of alpha carbon you write it, and then CHO. Then second molecules required for the reaction, write it just below it, CH3 CH2 CHO. Then remove this water molecule, then you will get starting from this carbon, okay, CH3, then it is attached to a CH2 group. Now there is one carbon with hydrogen. Now double bond O has gone, so double bond is left, and then it is attached with the alpha carbon of the first molecule. Then alpha carbon is attached with one CHO group and one CH3 group. So alpha, beta. So this is the same answer we got in the previous example. You can go back and then see it. So these are the two examples. So this is the this is an easy way for this aldol condensation reaction to get the product. You can use this one. If you need the mechanism, you can use the previous one. If you just need the final product, you can use this. Always remember the final product you are getting is an alpha beta unsaturated aldehyde. Hope you got the concept. Thank you.